Hello. We are going to take a look at an equation that we looked at earlier, but this time we're looking at it from the perspective of an inequality. So let's take a moment to read. It says the number of milligrams of a medication in a person's system, M after T hours, is given by the function M of T equals 20 e to the negative 0.4 T. So T, we know, is hours. And this M is milligrams of med. So, reading the first bullet point, the medication is effective as long as there are more than 2 milligrams. So I'm underlining more than 2 milligrams because that's the idea of an inequality. An inequality is that greater than, less than, greater than, equal to, less than, or equal to. So more than 2. When is the medication effective? Well, we've already looked at this example as an equation. And so this time we're going to take it as an inequality, but we're also going to use the graph. So I'm going to go out to my graphing calculator and get this all set up. So going to my y equals, clearing out the last thing that I had in. And so my formula here is 20 and then e to the negative 0.4x. My question that I'm looking at says, as long as there are more than 2. So 2 is the place where it is no longer effective. So 2 is right on the line, and so I want to graph my second y equals as 2 to find out where that line is. Then I want to take a look at what the values are. So I'm going to go second and window to set up a table. I'm going to start at 0, and I'm going to go up by 1s. I'll use second and the graph button, and this will allow me to look at values. So I see here that the number of milligrams started at 20 and is dropping rather rapidly. And sometime between the 5th and 6th hour, it goes from more than 2 to less than 2. I'm going to make my graph go up to 10 so that I see that answer, which is somewhere between the 5th and 6th hour, and I see beyond that. So I can clearly see what is above 2, what is below 2. So I will go to my window to set this up. So in my window, I decided I wanted to go from 0 to 10, knowing my answer is between 5 and 6. And in the y direction, my maximum amount was 20. So I will set this to go from 0 to 20. I'll take a look at the graph. All right. So the blue line was the equation, which is the number of milligrams, which I saw was dropping. The red line is the line at 2, and where they meet is that breaking point between when it's effective and when it's not. So in order to find that point where they meet, I'm going to use my calculator. I'm going to use second and the trace button, and I will choose option number 5 to find the intersection. I'll hit enter for first curve, enter for second curve, enter for guess, and I get an answer of 5.756. And there's more decimals there, but I'll round to 3 decimal places. So going back to the problem, let's take a look at what we've got going on. So I'm going to sketch out my graph here so that I can reason with it. We said T, which was the input variable, was the hours. So I'm going to label my graph. We set it up to go 0 to 10. Output over here was milligrams, so that's my y-axis, and we set it to go up to 20. We had the graph of the number of milligrams come as a concave up curve, swooping down, so decreasing curve. And then I put a line across at 2. And we found the point where these two met was at 5.756, 2. In this ordered pair, based on the labeling that we did, the 5.756 is the hours, the 2 is the milligrams, because that is an X and Y ordered pair. So the medication is effective as long as there are more than 2. So more than is that idea of greater than. So this medication is effective if the value for the function is greater than 2. And I can see that this area up here is larger than 2. So this whole section is above 2. And then here at the 5.756 hours, it's exactly 2. And after that, it's less than 2. So when is the medication effective? It appears to be effective from 0 to 5.756 hours. Now, because it is a word problem and a real life problem, I'm not getting real concerned about the greater than or equal to, less than or equal to. But sometimes it's nice to think that through. So it looks like it's effective starting at 0 when the patient takes the medicine. So 0 would be the lower boundary. The t is the time. That's the variable that's in the middle of this. And the 5.756 is the upper boundary. Now, exactly equal to 0, I guess they're still swallowing the medication. So I think that would be not having an equal to. And then this says it's effective as long as they're more than 2. At this moment in time, at the 5.756 hours, it's exactly 2. So again, I would think it would be up to that. So I would not include the equal to in this problem. But that's my opinion. And I would rather you answer in words, like I have up here, showing that that you understand where the graph is greater, than worry too much about the inequality symbols. And you'll see that your homework has some multiple choice options there with getting the right inequality. And so not something to stress over about the greater than or equal to, less than or equal to, but getting the words. What section of the graph is going to answer this question? Final question then is, when should the patient take a second dose? Give your answer as a whole number. And so this one does not follow the normal rules of rounding, which is why I put it in our notes so that we can talk about it. So in our normal rules of rounding, we would round the 5.756 hours up to 6 hours because that is the closest whole number. But if the patient waits till 6 hours to take the next dose, there's going to be a lapse in when their medication is effective. And so I would say that the patient should take the next dose at the 5-hour mark. And then there would be a little time where they would have sort of 2 doses of medication in them. The one has not quite worn off, but the other one is getting started. Because, and I say this 5 hours because if they wait till 6 hours, you would have a period of time where there's no medication being effective. So if I wait till 6 hours, there's a time when med level is not high enough. To be effective. So I hope that helps you reason through this idea of solving an inequality based on a graph. And much of the solving is exactly like solving an equation, which is where we did the crossing graph method and we put the 2 in. And then the difference is how we interpret the answer. So instead of saying the answer is one number, 5.756 hours, the answer is actually from 0 up to 5.756 hours.